Hello, my name is Angelica Coriano. I'm a bachelor's student at Valencia College in the Electrical Engineering Technology degree. This video is my video submission for lab number 3 for CET 2114C, which is Digital Systems. This video submission will include parts 1 and 2, beginning with part number 1. Alrighty, beginning with part number 1, we're going to begin with looking at the circuit we're going to build, which is right here. It is an AND gate with input A being connected to a 1 hertz clock signal, and input B being connected to switch number 1. I'm going to show it right over here. This is my circuit. So I have pin 1 connected to this green wire, which is connected to the 1 hertz clock signal. It's also connected to LED number 2 right over here. And then we have pin number 2, which is right over here, connected to this jump, which is this green wire going to switch number 1. So pin 1 connected to the clock signal and to LED number 3, and with pin 2 connected once again to switch number 1. We have the output, which is pin number 3, jumped over here to LED number 1. So LED number 3 is input A, which is the square wave signal, and the LED number 1, which is right here, is the output X of this AND gate connected to the square wave signal and to the switch. And then we have ground connected to pin number 7, and the 5-volt VCC going to positive, and pin number 14 connected to positive. And that is my circuit. Let me move my hand. And now, beginning with the first part of part 1, it says to set switch 1 to high and observe the output X. I'm just going to turn on the lab kit. We have a blinky light, which is the square wave signal, and LED number 3. I'm going to set switch number 1 to high. Over here. And we have now 2 blinking lights. Let me focus in. That is my circuit right there. So set switch 1 to high, observe the output. If X is enabled, this means the output signal is passing through the gate. If X is disabled, in this case, the output X is enabled because we have both lights blinking, meaning since switch 1 is on high, anytime that the clock signal is high, it's going through the gate. And this Boolean theorem that it's proving is Boolean theorem number 2, which is X and 1 is equal to X. Alrighty, now part G says set switch 1, I'm going to focus, low and record the output X. So I'm going to focus in, we're going to bring it to low. And with that, I only have LED number 3 blinking, which is input A, but the output X is no longer blinking. So the output X is disabled in this case. It has been disabled. And the Boolean theorem that this proves is Boolean theorem number 1, which is X and 0 is equal to 0. So now, moving on to part J, it says remove input B from switch 1 and tie it to input A. This means input B and input A are connected to the same 1 hertz signal. Luckily, I have the 1 hertz signal jumped on this row. So I just disconnected pin 2, which is input B, from the switch. And I moved it here to this row that has the clock signal. So input A is connected to the clock signal in pin 1, and input B in pin 2 is also connected to the same square wave clock signal. So I'm going to turn this on. And we have 2 blinking lights. Remembering that LED number 3 is input A, connected here in the same row as input A and B, well, A and B in this case. And LED number 1 is the output, which is pin 3 of the AND gate. So I'm going to show this here. I'm going to focus here one more time. So this means input B. What do you observe? Observing that both LEDs are blinking. This is actually Boolean theorem number 3, where X and X is going to be equal to X. Okay, so now moving on to part 1, letter L of this lab, we have this AND gate, which has input A connected to a 1 Hz signal, and then input B is input A passed through an inverter. So I have my circuit right here. I'm going to try to explain it as best I can. One thing I didn't mention, the chip I was using earlier was 74LS08. That is the AND gate chip. And the inverter chip I have right here on the left is 74LS04. So going through this circuit, we have the 1 Hz square signal in this row. I'm going to focus in, which has one wire going to LED number 3. Then we're going to go back to this row. We have the other wire, this green wire right here, connected to input A of the 74LS08 chip, which is the AND gate. So pin 1 of the AND gate, which is the 74LS08, is connected directly to the clock signal. Then we have another wire connected to the same row, to the same clock signal, going to pin 1 of 74LS04, which is the inverter. And then pin 2 of the inverter, which is the output, is connected to pin 2 of 74LS08, which is input B of the AND gate. So pin 2 of the inverter is connected to pin 2 of the AND gate, the output of the inverter to input B. Then we have output X, again in this case, or pin 3 of the AND gate, which is the output, connected to this wire, which is connected to LED number 1. We again have the 5 volts VCC connected to the positive rail, and pin 14 on the 74LS08 chip. They're not in the same, just going to show that the green wire is not connected there. So pin 14, I just want to show that the green wire is not connected there. Pin 14 of this chip and pin 14 of 74LS08 connected to the positive rail, and pin 7 on both connected to ground, which is connected to this ground right here. And that is my circuit for part L. So now I'm just going to turn this on, and I have my LED number 3, which is the square signal blinking, and LED number 1 is off. So the output is always 0. Boolean theorem is proven in this step. It is Boolean theorem number 4, which is X and inverse of X is equal to 0. And that is what we've proven here. So moving on now to part number 2 of this lab, we're going to be constructing this circuit right here, which is an OR gate, and input A is going to be connected to a 1 Hz clock signal, and input B is going to be connected to switch number 1, with input A having it being connected to an LED, and output X also being connected to an LED. So here is my circuit. Let me move my hand. I'm going to explain a little bit more about how it's connected. And now to see how this circuit is connected, we have the 1 Hz clock square wave signal connected to this row. I'm going to focus in a little bit. To this row, which has a wire connecting it to, this is IC chip 7432, which is the OR gate. So pin 1 is input A, and it's connected to the square wave. Pin 2 is input B, and that is connected to switch number 1. Pin 3 is the output of the OR gate on this chip, and it is connected to pin number 1. LED number 1. And LED number 3 is yet again connected to the clock signal to show that input A. And we have ground connected to pin 7, and the 5 volt VCC connected to the positive rail, which is connected to pin number 14. And that is how this circuit is wired. So the first part, letter E of part 2, it says set switch 1 high and monitor the output. So I'm going to come here. I'm going to turn the circuit on. And I'm going to set switch 1 to high. And we have our input A blinking, but LED number 1 is a solid red light. So X is actually disabled because it is a solid light. It isn't blinking. So I'm going to put that there, disabled. Since we have that light. And the Boolean theorem that is proven in this step is number 6, Boolean theorem number 6, which is X or 1 is equal to 1. So now moving on to G, says set switch 1 low and monitor the output. So I'm going to come here. I still have it on high from the last part. I'm going to set switch 1 to low, and then we have 2 blinking LEDs. So X is actually enabled in this case because the LEDs are blinking. And the Boolean theorem that is proven here is Boolean theorem number 5, which is X or 0 is equal to X. So Boolean theorem number 5. So moving on now to J, it says remove input B from switch 1 and tie it into input A. So both A and B are connected to the same 1 Hz signal. All I did here was I removed it from the switch and I took pin 2, which is input B, and connected it to this row, which is connected to the square signal. I'm going to turn this on. And we get 2 blinking lights, which means that output X is enabled. So my observation is that both LEDs are blinking. And this Boolean theorem that is proven is Boolean theorem number 7, which is X or X is equal to X. So now moving on to part L of part number 2, we have input A, which is the 1 Hz signal, passed to input to pin 1 of the inverter, and then input B is input A passed, my fault, I misspoke. So input A is the 1 Hz signal and it's going to pin 1. Input B is actually input A passed through a inverter, through a NOT gate. I'm going to show it right here. So all I did here, I added my 74LSO4 chip, which is the NOT gate. And this is still the row with the 1 Hz square signal. So I have, it's kind of tied into each other. Let me pull this one down. 1 Hz square signal going into my 7432 chip, which is the OR gate, to pin 1, which is input A. Then I have another wire going from the square wave signal into the 74LSO4 chip to the input, which is pin 1. And the output, which is pin 2, is connected to pin 2 of my OR gate because it is input B. So input B of the OR gate is the square wave signal passed through this inverter. This signal still has an LED connected to it, LED number 3. The output of the OR gate, which is right here, hope I've been saying that right in all the videos, is connected to this LED, LED number 1. So now I'm going to turn on the circuit. Focus in a little bit there. And we have LED number 3 blinking, which is the square wave, and LED number 1 is solid. So the output is always high. What Boolean theorem is proven in step N? The Boolean theorem, since they're both connected to the same, to an inverter, so it's going to be Boolean theorem number 8, which is X or inverse of X is equal to 1.